April 22, 1945. Outside Pilsen, Czechoslovakia. The rain falls in cold, steady sheets across the muddy courtyard of a captured Wehrmacht supply depot. In the shadow of a corrugated iron shed, Ober-Engineer Werner Schulze stands before a vehicle that should not exist. It is a truck, an American GMC CCKW, what the GIs call a deuce and a half. Its olive-drab paint is scarred with dried mud and scratches from 1,000 kilometers of hard use. The canvas cover over the cargo bed is torn in 3 places. One headlight is shattered. The front bumper is dented. And yet the engine idles with a steady, almost musical purr, as if the truck has just rolled off an assembly line in Detroit, rather than surviving 2 years of European combat. Schulze is a graduate of the Technical University of Berlin, class of 1936. He has spent 4 years designing transport vehicles for the Wehrmacht, optimizing every component for maximum efficiency and minimum material cost. He has studied metallurgy, stress analysis, power-to-weight ratios. He knows trucks the way a surgeon knows anatomy. And as he walks slowly around this American machine, his trained eye cataloging every detail, he feels something close to vertigo. This truck violates every principle of German engineering. It is too heavy. It uses too much steel. The components are standardized beyond any rational need. The engine is absurdly overbuilt, with a power output far exceeding what the vehicle's weight and purpose require. By every metric Schulze has been taught to value, material efficiency, theoretical optimization, precision manufacturing, this truck is wasteful, crude, almost primitive. And yet it works. More than works. Thrives. The odometer shows 68,000 miles. 68,000! Schulze's own designs rarely survived 15,000 before requiring major overhauls. He opens the hood and stares at the engine block. It is massive, heavy cast iron, where German designs use lighter alloys. The cooling system is over-engineered, with a radiator large enough for a vehicle twice this size. The electrical system uses components so robust they seem designed for industrial machinery rather than a military truck. Everything about this vehicle speaks of excess, of abundance taken to the point of absurdity. In his leather satchel, Schulze carries a clipboard with pages of calculations and specifications. He has been sent by what remains of the Wehrmacht Logistics Command to examine captured American equipment and determine how the Allies have sustained their offensive across France and into Germany itself. The question has haunted German planners for months. How do the Americans keep moving? How do they supply armies advancing on multiple fronts simultaneously? How do they maintain vehicle fleets that operate continuously, day and night, in all weather, without the constant mechanical failures that have crippled German logistics since Stalingrad? Schulze climbs into the driver's seat. The interior is Spartan but functional. The controls are simple, so simple a farmer could operate them with minimal training. There is no finesse here, no precision engineering, just brute functionality. He finds the maintenance log wedged behind the sun visor. It is water-stained and dirty, but legible. The truck has been serviced 11 times in 2 years. 11 times. Oil changes, tire rotations, 1 replacement starter motor. That is all. No transmission overhauls, no engine rebuilds, no replacement of worn precision parts. The truck has simply worked. He thinks of the Opel Blitz trucks he helped design, vehicles built with German precision and efficiency. They were lighter than this GMC, used less steel, had better fuel economy on paper. They were supposed to be the backbone of Wehrmacht logistics, and they failed. Not catastrophically, not all at once, but steadily, inevitably. Transmissions wore out. Engine blocks cracked in winter cold. Electrical systems failed in rain. Parts were not interchangeable between production runs because small improvements were constantly being implemented. Each truck required a skilled mechanic who understood its specific quirks and variations. And in the vastness of the Russian steppe, in the mountains of Italy, in the hedgerows of France, those skilled mechanics were in shorter and shorter supply, while the trucks broke down in greater and greater numbers. Schulze climbs down from the cab and walks to the rear of the vehicle. He pulls back the torn canvas cover and examines the cargo bed. It is empty now, but the wood planking is worn smooth from use, and there are stains, oil, fuel perhaps, that speak of years of constant loading and unloading. He runs his hand along the frame rail. The steel is thick, almost crude in its heaviness. This is not precision engineering. This is something else, something the German technical universities never taught him to recognize or value. Around him, the captured depot stretches into the rain. Hundreds of vehicles sit in neat rows. American Jeeps, British lorries, Canadian trucks, even some Soviet gas models. All captured during the desperate German counteroffensives of late 1944 and early 1945. All now sitting idle because the Reich no longer has fuel to run them, mechanics to maintain them, or armies capable of using them. Schulze has been examining these vehicles for 3 days now, measuring, documenting, trying to understand. And slowly, with the terrible clarity of a man watching his worldview collapse, he is beginning to see what German intelligence never grasped, what the technical specifications never revealed, what all the reconnaissance photographs and captured documents never conveyed. The Americans have not simply outproduced Germany, they have outthought it. They have built a logistics system based on principles so alien to German military doctrine that the Wehrmacht's planners could not even perceive them, let alone counter them. And now, standing in the rain beside this battered, ugly, indestructible truck, Werner Schulze understands that Germany lost this war not at Stalingrad or Normandy or the Bulge, but in the design studios of Detroit, in the steel mills of Pittsburgh, in the assembly plants where American workers, many of them women, he has read, built trucks like this one at a rate of 800 per day. 800 per day. The number is obscene, impossible, and yet true. He opens his satchel and begins to write. Not a technical report, not yet, just observations, calculations, the desperate notes of a man trying to explain to himself how everything he believed about engineering, about warfare, about the superiority of technical education and precision manufacturing could be so comprehensively wrong. The rain continues to fall. The GMC's engine continues its steady idle, and Werner Schulze begins to calculate why the United States Army can move 12,000 tons of supplies every day, while the Wehrmacht, with all its technical sophistication and tactical brilliance, is starving. The story begins not in 1945, but in 1940, in the offices of the Wehrmacht's quartermaster general in Berlin. German planners are studying the logistics of the French campaign, and they are satisfied. The Blitzkrieg has worked exactly as designed. Fast-moving panzer columns supported by tactical aircraft have shattered French and British defenses in 6 weeks. Supply lines stretched but never broke. Fuel trucks and ammunition convoys kept pace with the advance. The system functioned. German engineering and tactical doctrine had proven superior. But there were problems, small ones, irritations rather than crises. Trucks broke down more frequently than expected. Spare parts were not always available. The diversity of vehicle types, Opel, Mercedes-Benz, Ford, even captured French and Czech models, created maintenance headaches. Each type required different parts, different expertise. The panzer divisions raced ahead while the infantry divisions marched on foot because there were never quite enough trucks to motorize everyone. These were acceptable inefficiencies, the price of rapid industrial mobilization, nothing that German organizational skill could not eventually solve.
Then came Russia, and the inefficiencies became catastrophes. The distances were too vast, the roads were too poor, the winter was too cold. German trucks, designed for European highways and temperate climates, failed by the thousands. Fuel froze in lines, oil congealed in crankcases, engine blocks cracked, transmissions seized. By December 1941, Army Group Center had lost more vehicles to mechanical failure than to Soviet action. The Wehrmacht, the most modern military force in the world, was requisitioning horses from Polish farms and using them to pull artillery through the snow because the trucks could not move. German engineers responded with characteristic thoroughness. They studied the failures. They issued winter modification kits. They redesigned components. They established field workshops and training programs for mechanics. They optimized, refined, improved. And still, the trucks failed. Not from lack of quality, but from lack of quantity. There were never enough spare parts, never enough mechanics, never enough vehicles to replace the ones that broke down. The Opel Blitz was an excellent truck when properly maintained, but proper maintenance required time, tools, and parts that simply did not exist in adequate supply. Wehrmacht logistics officers began to notice something strange in intelligence reports from the Eastern Front. Soviet truck columns were moving with surprising consistency. Not because Soviet vehicles were better, they were often worse, crude copies of obsolete American designs, but because the Soviets had them in such enormous numbers that mechanical failures did not matter. If 10% of trucks broke down, there were always more trucks. If a convoy lost vehicles to air attack, replacement vehicles appeared within days. The Soviets were not out-engineering the Germans, they were outnumbering them.
And then came the intelligence reports from North Africa. British forces were using American trucks. Thousands of them. Studebakers and Dodges and GMCs shipped across the Atlantic under something called Lend-Lease. German reconnaissance units captured several and sent them back to Germany for analysis. Technical teams examined them with the same confusion Werner Schulze would feel 4 years later. These American trucks were heavy, overbuilt, wasteful of materials. They used outdated engineering solutions. Cast iron where aluminum would be lighter, electrical systems with redundant components, engines with power outputs far exceeding requirements. They were, by German standards, primitively designed. And they never broke down. British logistics officers reported operational readiness rates above 90%. 90%! German trucks rarely achieved 70% even under optimal conditions. The Americans were somehow building vehicles that worked in desert heat and Arctic cold, that could be maintained by minimally trained personnel, that could absorb damage and keep running, that could go 30,000 miles between major overhauls. It made no sense. German intelligence offered explanations. American trucks were over-engineered because American industry was wasteful and inefficient, unable to optimize designs the way German engineers could. The high operational readiness was a statistical anomaly, or propaganda, or the result of unrealistically high supply levels that could never be sustained. The Wehrmacht's own trucks were superior in design. They simply needed better supply chains, more spare parts, improved field maintenance procedures. The problem was not the vehicles. It was the logistics system supporting them. This belief persisted even as American trucks began appearing in larger and larger numbers. In North Africa, then Sicily, then Italy, then France. Everywhere the Allies landed, GMC trucks followed. They moved troops, ammunition, fuel, food, medical supplies. They drove through mud that stopped German vehicles. They operated through winter storms that froze Wehrmacht convoys. They absorbed battle damage, shrapnel holes, small arms fire, even artillery fragments, and kept running. And they did this not occasionally, not as exceptional performances, but routinely, consistently. as if mechanical reliability were simply a default state rather than an engineering challenge. By 1944, German logistics officers were no longer dismissing American trucks as primitive. They were studying them with increasing desperation, trying to understand how the Allies sustained offensives that, by German calculations, should have stalled for lack of supplies. After the Normandy invasion, Wehrmacht intelligence estimated that Allied forces would require weeks to build up sufficient logistics infrastructure to break out of the beachhead. Instead, American trucks began rolling off Liberty ships directly onto makeshift roads, and within days they were moving thousands of tons of supplies inland. The breakout came not weeks, but days after the landing. German defensive plans, calibrated to the Wehrmacht's own logistics limitations, were obsolete before they could be implemented. Werner Schulze knew none of this in detail as he examined that captured GMC in April 1945, but he understood the principle. He had spent years designing trucks to minimize material cost, to maximize theoretical efficiency, to achieve performance targets with the least possible weight and the finest possible tolerances. He had been trained to see engineering as optimization, as the elimination of waste, as the pursuit of elegance through precision. And he had been wrong. Not slightly wrong, fundamentally, philosophically wrong. The GMC CCKW, the designation means almost nothing to civilians, but to American logistics officers it represents a revolution in military thinking, was designed in 1941. Not by a single brilliant engineer, but by a team at General Motors working under contract from the U.S. Army Quartermaster Corps. The design requirements were simple to state and nearly impossible to achieve. The truck needed to carry 2.5 tons of cargo. It needed to operate in any climate, from Arctic to tropical. It needed to be maintainable by personnel with minimal training. It needed to use standardized parts that could be manufactured by multiple contractors. It needed to be reliable enough that a unit could depend on 90% operational readiness at all times. And it needed to be simple enough that production could be ramped up to hundreds of thousands of units without specialized manufacturing equipment or highly skilled labor. Every one of these requirements violated German engineering doctrine. German trucks were optimized for specific purposes and conditions. A vehicle designed for the Russian front would be different from one designed for North Africa. This allowed for maximum efficiency in each environment, but it meant that parts were not interchangeable, the mechanics needed specialized training, that production lines could not be easily converted between models. The German system was brilliant in theory. It was fragile in practice. The Americans took the opposite approach. They designed one truck, one model, and they built it in such enormous numbers with such absolute standardization that it became a universal solution. The GMC CCKW was not optimized for any specific environment. It was adequate for all of them. It was not the lightest or fastest or most fuel-efficient truck possible. It was the most reliable, and in warfare, reliability is worth more than elegance. Schulze finds the technical manual in the GMC's glove box. It is printed on cheap paper, already yellowing and water-damaged, but it is complete. Every system, every component, every maintenance procedure is documented in clear, simple language with detailed diagrams. He pages through it slowly. The manual assumes the mechanic has almost no prior knowledge. It explains not just what to do, but why. It includes troubleshooting guides, parts diagrams with standardized numbers, even instructions for field-expedient repairs using minimal tools. This manual could turn a farm boy into a competent truck mechanic in a matter of weeks. German maintenance manuals, by contrast, assumed significant prior technical knowledge. They were precise and comprehensive, but required educated mechanics to interpret them. This was not a flaw in German thinking, it was a feature. The Wehrmacht expected its mechanics to be trained professionals, graduates of technical schools, men who understood machinery at a fundamental level. But there were never enough such men, and as the war ground on and casualties mounted, the skill level of replacement mechanics declined. By 1944, many Wehrmacht repair units were staffed by hastily trained conscripts who could follow procedures but could not diagnose problems or improvise solutions. The German system demanded excellence. The American system assumed mediocrity and compensated for it. This philosophy extended to every aspect of the GMC's design. The engine, a 270 cubic inch inline six-cylinder, produces 104 horsepower. This is far more than needed to move a 2.5-ton truck at reasonable speeds. German engineers would have designed a smaller, lighter engine producing exactly the power required. But the Americans overbuilt it deliberately. The excess power meant the engine never operated at maximum stress. It could lose cylinders to battle damage or poor maintenance and still function. It could run on low-quality fuel without knocking. It could pull far more than its rated load in emergencies. The engine was not efficient. It was indestructible. The same philosophy applied to every component. The transmission was massively overbuilt, with gear teeth twice as thick as necessary by German calculations. The axles were reinforced beyond any rational stress analysis. The electrical system used components rated for industrial use rather than automotive applications. Everything was redundant, excessive, wasteful, and everything worked continuously in conditions that would have destroyed a German truck in days. Schulze makes notes, sketches, calculations. He measures the thickness of the frame rails, the diameter of the drive shaft, the capacity of the fuel tank. He examines the tire treads and notes that they are worn but not failed, 68,000 miles on what appear to be the original tires, with perhaps one rotation and some patching. He inspects the brake system and finds it hydraulic, not mechanical, less efficient in theory, but self-adjusting and requiring no specialized knowledge to maintain. Every detail reinforces the same lesson. American trucks were not designed to be perfect. They were designed to be good enough and to stay good enough, no matter how badly they were treated. But the real genius, Schulze begins to understand, was not in the truck itself. It was in the system that produced and sustained it. He has read intelligence reports about American manufacturing. He knows that GMC built these trucks in Michigan, but that dozens of other companies built identical trucks under license. That the engine might come from one factory, the transmission from another, the axles from a third, but every component was interchangeable. That parts were standardized not just within the Army, but between the Army, Navy, and civilian sectors. That a mechanic in France could requisite a starter motor and receive one manufactured in Ohio, or California, or Texas, and it would fit perfectly, because all the starter motors were identical. This was the concept that German industry never fully embraced. German manufacturers competed with each other for military contracts, each offering their own proprietary designs. Opel trucks used Opel parts. Mercedes-Benz trucks used Mercedes-Benz parts. Cross-compatibility was minimal. This meant that a supply depot needed to stock hundreds of different parts to support a mixed vehicle fleet. It meant that a damaged truck might sit idle for weeks waiting for a specific component, while identical trucks from different manufacturers operated nearby, unable to share parts. It meant that production could not be easily scaled because each manufacturer's designs required specialized tooling and skilled labor. The Americans had solved this problem not through superior engineering, but through industrial organization. They had created a system where competition happened at the design stage, but once a design was selected, everyone built to the same specifications. Where parts were manufactured by the lowest bidder, but every part met the same exacting standards. Where a truck built in Detroit in January was identical to one built in California in December, down to the threading on every bolt. The system was not elegant. It was not innovative. It was simply massive, coordinated, and absolutely relentless.
Schulze thinks about the numbers. He has seen them in captured documents, in intelligence summaries, in the bitter reports from Wehrmacht logistics officers trying to explain why German counterattacks stall while American advances continue. The United States produced 562,000 GMC CCKW trucks between 1941 and 1945. 562,000 of one model. This does not include the other truck types, Studebakers, Dodges, International Harvesters, Ford GTBs. Just the GMC. Just one standardized design rolling off assembly lines at a rate that seems physically impossible. Germany, by contrast, produced approximately 100,000 military trucks of all types during the same period. 100,000 across dozens of different models, none fully interchangeable, none manufactured in numbers sufficient to create economies of scale. German industry was not incompetent. It was not lazy. It was simply operating on a different scale, guided by different principles. German engineers designed excellent trucks, each optimized for its specific role. American engineers designed one adequate truck and built 500,000 of them. The strategic implications are staggering. An American armored division in France requires approximately 400 trucks to sustain operations. If 10% break down, a typical rate for any vehicle fleet, that is 40 trucks out of service. But because parts are standardized and abundant, most of those 40 can be repaired within days, often within hours. Field mechanics carry common replacement parts in their own trucks. Spare vehicles are available in depot pools. The division's operational readiness rarely drops below 90%. A comparable German Panzer division requires similar numbers of vehicles. But the Wehrmacht's operational readiness rates hover around 60%, sometimes dropping as low as 40% during sustained operations. This is not because German trucks are inferior. It is because, when they break, repairs take longer. Parts must be requisitioned from centralized depots. Specialized mechanics must be located. Sometimes vehicles are cannibalized for parts because no replacements are available. The division continues to function, but every action, every movement, every operation must be calibrated to the reality that nearly half the transport vehicles may be unavailable at any given time. This gap compounds over time. An American division can sustain continuous operations for weeks, resupplying itself through truck convoys that move day and night. A German division must pause regularly, not because of enemy action or tactical considerations, but simply because the logistics chain breaks down. Trucks that could be repaired in hours remain idle for days. Convoys that should take 6 hours take 12 because vehicles break down en route and the entire convoy must wait. Attack plans that look brilliant on paper founder because the fuel trucks do not arrive, or the ammunition convoy gets stuck, or the food supplies never leave the depot. Schulze does the mathematics. If the Americans can maintain 90% operational readiness and the Germans can maintain only 60%, the effective transport capacity gap is not 30%, it is 50%. The Americans can move 50% more supplies with the same number of trucks. And because they have 5 times as many trucks to begin with, the actual capacity advantage is 7-to-1. 7-to-1! No amount of tactical brilliance can overcome a 7-to-1 logistics disadvantage. This explains why American offensives do not stall, why Allied armies advance continuously, even when German commanders believe their supply lines must be stretched to breaking. The supply lines never break, because they are overbuilt by design, redundant in every component, sustained by a replacement system that assumes constant losses and compensates for them automatically. German intelligence keeps predicting that American advances will outrun their logistics, and American advances keep proving those predictions wrong, not because American generals are bolder, but because American trucks keep moving. There is a deeper pattern here, something that transcends engineering specifications and production statistics. Schulze senses it, but cannot quite articulate it. The American truck is a physical manifestation of a worldview, a philosophy about how complex systems should be organized. It embodies assumptions about the value of individual components versus collective function, about the virtues of simplicity versus sophistication, about the relationship between standardization and innovation. German engineering education taught optimization. Every component should be refined to theoretical perfection. Unnecessary weight was a flaw. Excessive capacity was waste. The ideal machine performed its function with minimal material and maximum efficiency. This philosophy produced remarkable individual designs: the Panther tank with its sloped armor and high-velocity gun, the Me-262 jet fighter, the Type 21 U-boat. Each was technologically superior to its Allied counterparts. Each was a masterpiece of precision engineering. And each was produced in numbers too small to affect the war's outcome. The Panther was an excellent tank, but it was mechanically complex, expensive to build, difficult to maintain. Germany produced 6,000 Panthers. The Americans produced 50,000 Sherman tanks. The Sherman was inferior in almost every technical specification, but there were always more Shermans. When one was destroyed, two more arrived. German panzer crews became expert at killing Shermans. It made no difference. The Shermans kept coming. This was the lesson Schulze is learning in the rain beside that captured GMC. Excellence is less valuable than adequacy at scale. A perfect machine that breaks down is inferior to a crude machine that keeps working. An optimal design produced in limited numbers loses to a good enough design produced in overwhelming quantities. The Americans understood something German engineering culture never grasped: that in total war, the system matters more than the component, that reliability matters more than efficiency, that the ability to repair and replace matters more than the elegance of initial design. The symbolic object that crystallizes this realization for Schulze is not the truck itself, but something simpler. In the GMC's tool compartment, he finds a tire iron. It is a single piece of forged steel, bent into a simple L shape, with one end flattened for prying and the other end socketed for lug nuts. It is crude, heavy, inelegant. A German manufacturer would have designed something lighter, perhaps with interchangeable heads, optimized for multiple functions. This American tire iron does two things. It removes tires and it pries stuck components. That is all. But it is indestructible. Schulze examines it closely. The steel is thick, the forging rough but solid. The socket end shows wear but no damage after 68,000 miles of use. This tool will outlast the truck. It will outlast the war. Some American GI will probably take it home to Iowa or Texas and use it for the next 40 years. It is a tool designed by someone who assumed it would be used by soldiers with no mechanical training, in terrible conditions, probably in the dark or the rain, possibly while under fire. So they made it simple and strong. They made it impossible to break or misuse. They made it good enough. This tire iron represents everything the GMC represents, everything American logistics represents. It is not the best possible tool. It is the best possible tool for the worst possible conditions used by the least trained possible operator. It is designed for a world where things go wrong, where people make mistakes, where conditions are never optimal. And in that world, the real world, the world of war, it is superior to any optimized, precision-engineered alternative. Schulze places the tire iron back in its compartment. He continues his examination, documenting everything, but his mind is elsewhere. He is thinking about the assembly lines in Detroit, running 3 shifts per day, producing 800 trucks every 24 hours. He is imagining the cargo ships crossing the Atlantic, carrying these trucks by the thousands to Europe, to Africa, to Asia. He is envisioning the logistics networks, the supply depots, the maintenance units, all built around the assumption the trucks will keep working and parts will always be available. He is seeing for the first time the full scope of American industrial power, not as statistics or intelligence estimates, but as a physical reality embodied in this single vehicle. The German war effort was built on the assumption of qualitative superiority. Better tanks, better aircraft, better tactics, better soldiers.
The Wehrmacht would win through excellence, through the superior training of its personnel and the superior design of its equipment. This was not arrogance, it was calculation. Germany could not match the population or industrial capacity of its enemies. Therefore, Germany must achieve more with less. A German soldier must be worth 2 Russian soldiers. A German tank must be worth 3 American tanks. A German truck must be more efficient, more capable, more sophisticated than Allied equivalents. And for a while, it worked. German tactical excellence achieved impossible victories. German equipment performed beyond expectation. But tactical excellence has limits. At some point, quantity becomes a quality of its own. At some point, the ability to replace losses matters more than the ability to avoid them. At some point, a force that can repair its equipment in the field and return it to service within hours defeats a force that must send damaged equipment hundreds of miles to specialized workshops. The Wehrmacht reached that point in Russia in 1942. It reached it again in North Africa, and again in Italy, and again in France. By 1945, German qualitative superiority no longer matters because there is nothing left to be superior with. The best designed truck in the world is useless without fuel or parts or mechanics. The most sophisticated weapon is irrelevant when the logistics network that sustains it has collapsed. Excellence becomes meaningless when the foundation supporting it crumbles. And that foundation, logistics, supply, the unglamorous work of moving material from factories to fighting units, is where Germany lost the war. Schulze closes his notebook. The rain is heavier now, drumming on the shed's metal roof. Around him, the captured American vehicles sit silent, monuments to an industrial philosophy that defeated the Reich more thoroughly than any battlefield victory could have. He thinks about the report he must write, the explanations he must provide to superiors who probably no longer exist or care. What can he tell them? That Germany was out-engineered? That is not quite right. Germany was out-systematized, out-organized, out-thought at a level so fundamental the German planners never recognized the battlefield. The war is ending. Everyone knows it, though few say it openly. In days or weeks, the Reich will collapse. Schulze will become a prisoner or a refugee. His engineering expertise will become either valuable to the victors or irrelevant in a defeated nation rebuilding from rubble. But this moment, standing in the rain beside an American truck, feels like the true ending. This is where ideology meets reality and breaks against it. This is where the assumptions of German technical superiority dissolve into understanding of American industrial democracy.
The GMC CCKW moved 12,000 tons of supplies per day across Europe at the height of the Allied advance in 1944. 12,000 tons. That is the weight of 90,000 soldiers fully equipped, or 600 tanks, or enough ammunition to sustain 3 corps in continuous combat. Every day, day after day, from the beaches of Normandy to the Rhine, from southern France to the Alps, American trucks moved an endless river of material that sustained the most rapid advance in military history. German commanders could not understand it. They kept predicting that American logistics must collapse, that the advance must stall, that the Allies would suffer the same supply breakdowns that crippled every German offensive after the first years of war. They kept waiting for the Americans to run out of fuel, ammunition, food. And the Americans kept advancing, supplied by convoys of GMC trucks that moved through rain and mud and snow, that absorbed battle damage and kept rolling, that required minimal maintenance and never seemed to wear out. The Germans were not stupid. They were educated, experienced, many of them brilliant. But they were trapped inside assumptions that made American success incomprehensible. They assumed that logistics was a limiting factor,
that armies could only move as fast as their supply lines could sustain them, that there were mathematical limits to how much material could be moved over primitive road networks. And all of those assumptions were correct for German logistics using German trucks with German maintenance doctrines. They were simply irrelevant to American logistics using American trucks with American systems. The United States did not solve the logistics problem by optimizing trucks. They solved it by assuming trucks would break down and designing the entire system to make breakdowns irrelevant. They overproduced trucks so that spares were always available. They standardized parts so that repairs were simple and fast. They overbuilt components so that failures were rare. They distributed maintenance capacity so that every unit could repair its own vehicles. They created redundancy at every level, from individual truck components to theater-level supply networks. The system was grossly inefficient by German engineering standards, and it was absolutely unstoppable. This was democracy as military doctrine, not in some abstract political sense, but in the concrete organization of industrial production and military logistics. The American system assumed that trucks would break down, and designing the entire system to make breakdowns irrelevant. They overproduced trucks so that spares were always available. They standardized parts so that repairs were simple and fast. They overbuilt components so that failures were rare. They distributed maintenance capacity so that every unit could repair its own vehicles. They created redundancy at every level, from individual truck components to theater-level supply networks. The system was grossly inefficient by German engineering standards, and it was absolutely unstoppable. This was democracy as military doctrine, not in some abstract political sense, but in the concrete organization of industrial production and military logistics. The American system assumed that individual components would fail, that individual decisions would be suboptimal, that individual operators would make mistakes. So it built in forgiveness. It created structures where failure at one point did not cascade into system collapse. It valued reliability over efficiency, standardization over optimization, abundance over elegance. The German system assumed that excellence could overcome scarcity, that superior design could compensate for limited production, that elite personnel could achieve more than mass mobilization. It was a system built for brilliant individuals, the ace pilot, the master engineer, the tactical genius. And when those individuals fell in battle or failed to be produced in sufficient numbers, the system had no fallback. Excellence admitted no substitute. Optimization left no margin for error. Schulze understands now why Germany lost, not because German soldiers lacked courage or German weapons lacked quality. Germany lost because the Wehrmacht fought World War II as if it were still World War I, as if tactics and operational art were decisive, as if battles won by brilliant maneuvering could compensate for strategic disadvantages in production and supply. The Americans fought a different war entirely. They fought an industrial war, a logistics war, a war where the decisive battles happened in factories and shipping depots and maintenance units, far from the heroic struggles of the front lines. The GMC truck is the weapon that won that war. Not the Sherman tank or the P-51 fighter or the atomic bomb. The truck. Ugly, crude, overbuilt, and absolutely reliable. Moving 12,000 tons per day, every day, until the Reich drowned in American material abundance.
Years later, long after the war, Werner Schulze will work as an engineer for Mercedes-Benz, helping to rebuild German industry. He will design trucks again, applying lessons learned from examining that captured GMC. He will advocate for standardization, for overbuilding components, for designing systems that assume imperfect conditions and imperfect operators. Some of his colleagues will resist, arguing that such approaches sacrifice German traditions of precision and optimization.
And Schulze will think about standing in the rain in Czechoslovakia, watching an American truck idle with a purr like contentment, and he will know what those colleagues cannot accept. Perfection is the enemy of good enough. Excellence is less valuable than reliability. Optimization is inferior to redundancy. These are not engineering principles. They are philosophical truths about how complex systems survive in chaotic environments. The Americans understood them instinctively, perhaps because American democracy itself is built on similar assumptions, that no individual should be irreplaceable, that systems should survive individual failures, that abundance can be organized to overcome scarcity. The GMC CCKW was produced until 1945 with over 500,000 built. After the war, thousands were sold as surplus, and they served in civilian roles for decades, as farm trucks, construction vehicles, utility haulers. Some are still running today, 80 years later, crude and heavy and indestructible. They have outlasted the Reich they helped defeat. They have outlasted the ideologies and armies and nations that fought over them. They endure as monuments to a simple truth that German engineers learned too late. In total war, the side that can keep its trucks running wins. Not the side with the best trucks, not the side with the most sophisticated trucks. The side whose trucks keep working day after day, regardless of conditions or operator skill or material scarcity. The side that builds logistic systems robust enough to survive everything war throws at them. The side that values reliability over perfection and abundance over optimization. The Americans built such systems. They built them into every component, every procedure, every organizational structure. They built them into the GMC CCKW. That crude, heavy, indestructible truck that moved 12,000 tons per day across Europe while German vehicles sat idle for lack of parts. And in building those systems, they demonstrated a truth about power that transcends engineering specifications and production statistics. True power is not the ability to achieve perfection. It is the ability to sustain adequacy at scale. It is not the capacity to create brilliant solutions, but the capacity to implement workable solutions universally. It is not the excellence of individual components, but the reliability of integrated systems. The Germans never learned this lesson in time to save themselves. But standing in the rain beside an American truck, Werner Schulze learned it. And the lesson was this: democracy, for all its inefficiencies and compromises and inelegance, possesses one decisive advantage in total war. It keeps the trucks running.